Hello everyone. Um all right. Sorry, starting a bit late today. This is because I had a bit of I don't know what to call it, but I've just been, caught behind time. We're not going to do much today. We're just going to solve um one or two questions, and then tomorrow we'll have a longer session, right? Visit a lot of things from tomorrow. All right, so let's see what we have here. Um, I'm just going to, I'm trying to set up a few things now. I really hope okay, so we're good now. This is all right. Um, trying to open my code editor. Okay. So today we are going to solve a question that we are going to revisit, right? Some question I solved previously. I will explain what the question really is, right? And we'll see the different techniques we can use to solve that same question. Now, I'm not going to, today's session is going to be explanation and, of questions I've solved before, right? So we are going to go into linked lists. I actually solved a couple of linked list related questions, which is why I chose linked list for today. We are going to solve every question tomorrow, right? Tomorrow is going to have a longer session. So I'm just doing this today to just keep the 100 days going. All right, so let's see. The question I chose for today was it's supposed to be two questions actually. I forgot to link the second one. The second one would be on merging two linked lists, right? So we have merge two sorted linked lists. Yes. So this is the first one. I'll just close the solution here. And this is the second one we'll be looking at, right? So these are the questions we'll have. All right. So we'll take a look at the add two numbers, then merge two sorted lists. I'll use the board here to make my explanation as usual. This is what I use to explain the questions, right? So if you're here for the first time, that's what we'll be doing. Okay, so we'll start with this one first of all. You are given two non-empty linked lists representing two non-negative integers with digits. The digits are sorted in reverse order. Sorry, let me go over that again. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their node contains a single digit. Add the two numbers and return the sum as a linked list, right? You may assume that the two numbers do not contain any leading zero except the number 0 itself. So I will explain what this question really is. I think I must have made this a little larger. All right. So we are giving um, two integers, right, that are represented in a whose digits, sorry, two integers are the inputs we are given, and the digit that the integer is made up of are stored in a linked list format, right? So which is what the question is saying here. Let me really make that clear again. So we're giving an input, right? Two inputs in this case. Now this is a single digit, right? I mean this is an integer, sorry. And the integer is stored in reverse order. And the digits that make up that integer is stored in a linked list format, right? So in this case, this would have been 342, but each of the integer from 342, sorry, is stored in a reverse linked list format, right? And then we have a second input in that format as well, and we're asked to sum the values, right, from each list, and return the um, the addition or the sum of the result in a linked list as well. So here is what we'll do. I'll bring that image here again so that my explanation is really good. Let me come back here. So let me explain again. We are given an input, right? So here's our input. This is our input, and we have, so what the question is saying is, this here was originally an integer, right? So here is going to be 243, but let's look at this again. The question says, okay, so you are given two non-empty linked lists representing two non-negative integers, right? The digits are stored in reverse order. But before we get to this part, let's understand what this really says. This says the list we are given, right, represent two non-negative integers. In this case, both of these lists, right? So we have the first list. The non-negative integer this would have represented would be 243, right? And we have this as well, which is 564, right? 243, 564. This is the original form, the original inputs, right? The original digits, integer that this linked list is made with, right? And each of the numbers in this integer, right, was used to form a linked list, right? So we create nodes with the values from this integer. Now, the second part of this says the digits are stored in reverse order, and each of their node contains a single digit. So meaning the digits are stored in reverse order, right? So maybe this wasn't the original form of our digits, right? Of our integer. So this would have been 3 4. So the original order of this would have been 3 4. Let me use a different color because that is not really important at this point. So 3 4 2, right? And this would have been 4 6 5. So the digits are stored in reverse order, and each of their node contains a single digit. Okay, so this here, right, was stored in a linked list, but the way it was stored was in this format. So let's say we turned this into an array, right? Let's say we splitted this into an array. So this would have been 3 4 and 2, right? And we try to create a linked list from this integer, right, or this array that we recently created. So to do this, we'll start something. So the list was formed in this way. This is how I'm guessing it. So it started from this part. So this would have been the head of the list, and then we have 4, and 3 was inserted last, which is the tail node of the list. Now that is how this list was formed, and this is not really what the question is asking us to do, but I'm trying to break it down for us to understand what the question is actually indicating and not to confuse ourselves with unnecessary details, right? At this point, this is just something you need to know. It's very trivial because we don't really need this to solve the question itself. We need it to understand the question, right? What the question is really asking us to do is to sum the nodes, right, from two linked lists, which is our inputs. So which is what we are going to do. But in order for us to really understand how we sum this, right, we also need to go back into the little details, the unnecessary details, which is what I'm doing now, right? So after we've seen this, right, we'll then know how we're going to go about the addition of the values. Now, because this linked list was originally created in reverse order, the addition will be done in that same order too. So meaning if we're to sum 243 with 564, right, we will not do the normal, the conventional addition, right? We will not go in the normal right to left direction. We are going to go from left to right. So we have 243 plus 564. So 243, 564. When we add these two values, right, normally what we would have done is we'll start from this point, right, and we'll say this is 3 plus 4, which is 7. This would have been 10, so we'll take out this will be 3, this will be 807. But this 807, right, which is actually correct, right? If you had done it this way, this is fine, right? But we don't want to store the 807 directly like this. We will need to store it in reverse order as well. So meaning we'll have to say this would have been 708, right? And we'll create a linked list from this answer, which is going to be 7, 0, and 8, right? When you look at the answer here, you can see this is the same thing we have here, but the addition was not done in a normal way. Even if you do it in a normal way, then you have to reverse the list again, right? You have to create a linked list, but in a reversed order. So now creating a linked list is not really hard, right? In terms of connecting the nodes, right? All you need to do to create a linked list is to have one main node, right? So you have, let's say for example, we have 7 as our first node, and with the properties of node in a linked list, you need to have, so this is how a node is in a linked list. So a node will be a class, and the property are such as we have the value, right, which is in this case 7, so the value will be an integer for example, and we'll have a next pointer, right? Now this is where the next node in the list will go to, right? If this node existed, this node with the value 7 existed as part of a linked list, right, then the next node that goes into that linked list will be connected to the linked list, or be inserted to the linked list with the next property of this node. So in this case, if I were to add another node to this linked list, right, I'll create the node and set the next pointer of this 7, right, this node with the value 7, to the new node that I want to insert in the list, right? In this case, we'll have 7, right, and if I wanted to insert 0, I'll create a node and set 0 to it and add it to the next pointer of 7, and this will go on, right? So in this case, we'll have 8, right? So I'll create my 8 node here, and then take 8 and then set the next of this 0 to 8. Now 8 meaning the node 8, not the value 8 itself. So we'll create a node each time and then insert that node into the list. So that's basically what's going to happen, and we'll create a new entire node from this whole for this addition, right? So let's take a quick a step back, right, and really understand how the addition is going to be done. Now with additions, right, we can't have we can't have values that are let me remove this part. We can't have a 2-digit value in a node, right? And just the way I did it here, let's perform the addition again of 243 with 564. So we have 2, let's use a different color, 243 564, right? This will be 7, this will be 10, we write 0, carry out 1, and we add it here. This will be 8. So we have 807, right? Now, this is our answer. But as you can see, when I was doing this addition, when I got to this point where 6 plus 4 is equal to 10, right? When I got to this point, I did not write 10. So I carried out 1 and then add it in my next sequence of addition. I mean, in my next step of addition, right? So this is very important, and we need to know how we can carry out values, right? With when it comes to adding nodes, adding values of nodes in a linked list, because we can't store. The question specifically stated that we could not store, values like this. So in this case, even though we can set any value for our node, right, for this particular question, we cannot have a 2-digit value for our node's value. So we needed to, exclude or, take away some value and then add it in the next sequence. And if you look at this very well, the addition was done from left to right, right? So we started adding values like this. So instead of doing it this way, which would now require us to reverse and create a new linked list, which is extra steps, right? We would need to do this, right? We'll need to take the value from here. So we'll do 2, 4, 3, 5, 6, 4, and then we start adding from this side, right? So this will be 5, 2 plus 5 is 7, 6 plus 4 is 10, we write 0 and we carry out 1, and then we add the value here. This already here is 7 plus 1 is 8, right? So we'll have our linked list with these values. So we'll connect it like this, we'll connect this to this one, and so on. Now, I would like to go over this again. I really want to explain this question in a way that really satisfies everyone's understanding, regardless of your of your level when it comes to data structures and algorithm. I really want everybody to get my explanation, right? I might, be really fast while explaining in the first half, but I'll go over this again and explain it properly. But before I do that, let me check if there are any questions, in the chat. All right, so I can see there are a few people here. Hello, welcome, guys. All right, how are you guys doing? So today we are back. All right, so there is no question. Then I can just go back to the main question itself and explain again. So let's take this back a little. Let's take back a little. This is blocking our board, so we'll bring the illustration here a little, right, so that it is properly focused. All right, since there are no questions, I will continue with the explanation. Okay, so we are given 2 linked lists, right? And the linked lists were formed from an integer. Now, the integer in this case has 3 digits. For the first list, we'll have an integer like this. So the resulting integer from this list here is 243. And in this case too, we have 564, right? So what the question is asking us to do is to sum the values from the lists, right, or the nodes values, right, and then return the resulting list from this addition. So now for us to do this, we need to know 2 things, right? We need to know the direction in which we want to add the values, because the question specifically stated that the resulting value is in a reverse form, right? Meaning originally this node here, right, this list here is not the actual value. I mean, in terms of arrangement of the digits, right, this isn't what it is, right? originally we would have had, you know, I think I must probably be saying something else. The we can assume, right? Let's read the question again for a better understanding. You are given two non-empty lists representing two non-negative integers, right? The digits are stored in reverse order, and each of their nodes contains a single digit. So, meaning this, while building this list, right, the original form um, of the integer that this list was built with was probably, you know, 3342, right? And then, you know, the list was built in a reverse form, right? So we can, I will also prove this again. So let's just say this was the original integer we had, right? And the list was formed, right? The linked list, let me remove this part. The linked list, I'll just put this here like this. The linked list was formed from 342, right? By probably starting from the end of the integer, right? Maybe this was converted into an array, and then we iterated to add each integer, or I mean each digit from this integer as a new node, and then we formed a linked list from it. And this is the linked list we have, the resulting linked list. Now, the same thing was done here, right? So I would say this was 4, 6, and 5. Now, when we add these values, right? Let's add these values here. This will be 7, this will be 10, so we'll add 0, this will be 8. So we have 807 when we add these values. Now, when you look at this, right, just to prove that the original form of this list was actually 342 and 465, right? The resulting addition was 807. Now, when we reverse this, we'll have 708, which is the reverse form. And the reverse form, when we create a list with the reverse form, right, we'll have our, you know, resulting value when we add the nodes from the reversed the list created from the reversed form of the actual integer, right? So this is not really important, right? In this case, we will not have to, you know, reverse the list and then start adding the digits from each node before reversing and returning the sum, right? The final result. That's not what we are going to do. What we really need to do in this case is to understand that our addition will not be done in a normal form, right? And by normal form, I mean when we are adding values, right, we add from this point to this point, right? We go from right to left. That's what we do. But since the question specifically stated that the nodes were not created, I mean, the lists were not created with the original form of the integer, right? And by original form, I mean the original placement of the digits in the integer itself, right? We need to do the addition from left to right. Now, again, once a list is created, I mean, we are not creating the list ourselves. The list was already given to us. This is just an information we needed to, you know, really break down and understand, right? So the list was already created, and the list was given to us as an input, and we need to iterate the list, right? We need to iterate the list or traverse the list, in other words, right, by visiting every node, and at each point we need to traverse the list simultaneously. Both lists, we need to traverse them at the same time, right? Once we start at this point, we have to be at this point of this list, and when we move to the next node, we also have to move so that the addition can be done and a new node will be formed at that point. So for us to do this, right, let's take a look at how the left to right addition will be done. Now this is the reversed form, right? And I'll just prove to you that this was really reversed from this point. So when we start adding values like this will be 7, here we'll have 10, this will be 0, right? And then we'll carry out 1, right? We'll carry out 1 and add it to this point. So this will be 3, 7, and this will be 8. So now when you look at this, right, you can see this is just a mirror version of this original string, right? 8 was at the end, but 8 is now at the beginning in this case, and so on, right? So this is what the question is really asking us to understand, right, before we move on to adding the values. Now, adding the values will really require us, like I said, traversing the list, right, both lists at the same time, and by the same time we are visiting we are traversing at the same pace. So if we move to the next node in this case, right, we have to move to the next node in this second list or the first list, and we sum the values within the values of the nodes at that point in time, right? So let's go back again. So first of all, when we get to this point, we add the values, right? So this is 2 and 5. 2 and 5 are added. Then we move to the next value. This is 4 and 6. Then we move to this next value. Now 4 and 6, here is where the problem comes in. 4 and 6 will give us a 2-digit value, which is not possible to store in a node in this question, right? We always need to have a single digit value for our nodes in this case. So since 10 is a 2-digit number, right, we need to write 0 and carry out 1, and then 1 will be added to this addition here, right? The result of this is 7. So by carrying out 1, we have to add that 1 to this 7 here, and then have 8, which is what we have here, right? This is 8. Originally, if we're going to sum the values, right, and just store them like that in the list, we would have had 10 here, and then here will be 7. But we can't store 10 like this. In normal addition, we have to carry out 1 value and then keep the other one. Now, carrying out value simply means we are dividing the value by 10, right? So meaning if we take 10 here and we divide it by 10, right, the answer here will be 1, right? This 1 is what we carry out, right? This 1 here is what we carry out, and what is left is the remainder of the division. So when we divide 10 by 10, what remains is 0. So we take 0 and then we create a new node with 0. And then that is the node we store at that point in our results linked list, which is this list here. So those are the 2 things we need to know: how to, carry out a value, right? In this case, this is going to be 1, and then how to store the actual value we want to store in the list, which is going to be 0. So a node can have 0 as value, except 0 cannot be at the front, right here, which is what the question is saying on this line. You may assume the 2 numbers do not contain any leading 0 except the number 0 itself, right? You can have a node like this, right? You can be given 2 linked lists, right? So one of the test cases when you submit the question, we can have a list with just 0, right? This is valid, but we can have a list with leading 0, right, where we have other values like this, right? This is not possible. We can't have leading 0, but we can have 0 itself as a node in a list. It can be at the beginning without any values following it, and we can also have it as part of the resulting nodes in the result list. Now, one thing we need to note is how we will traverse the list, right? How do we traverse the list at the same time and ensuring that we are adding the values at each point? So traversing list traversing a linked list is quite simple, right? So all we need to do is to start from the head of the list and then find the next node, right, by using the next pointer. So when we want to get to the next node, right, let's take a list. For example, we had a list like this. So 4, 6, 3, right? This is our list, and then we want to traverse this list up to this point. All we need to do is to ensure that the list that we are currently at, right, has a next node, right? The next value of this node actually points to a node in the list, and then we'll do the same thing here, right, by checking the next of this one until when we check the next, right, the tail node usually has null, right? So this will be null, and we can't continue searching, right? We can't continue searching for the next node and so on. So that is what we need to do. But there also, we need to also know whether both lists that will be given will have the same amount of nodes. Now, that is not going to be the case in this question. There will be a case where a node has just, less, a list has less node than the other, right? We are given two lists and want to sum the values in those lists, right? So a list can have less values, less nodes, right, than the second list. So in that case, it means when we are traveling the list simultaneously, we would have reached the end of one list, and then we'll still keep, searching. And this will be impossible if we don't, handle the edge cases for that, right? So in the case where both lists do not have the same amount of nodes, right, we need to ensure that we are able to take care of that. And by taking care of that, I mean in terms of code, right, we need to write the code that will actually keep iterating as long as there are nodes in the next, in either of the lists, right? So let's say, for example, in this case, right, we have a node 4, 4, 6, 3, and then we have another node, right, 3 and 1, right, with two nodes. And I mean by node, I was going to say list, right? We have a second list with 3 and 1 as its nodes. So meaning when we are traversing and summing up the values, right, what we'll have is here we'll have 7, and then we'll have 8, and then we'll still be able to add the values here, right? Despite the fact that this here is a tail node, right, we can add null to 3, but we'll still need to be able to take care of it, right? So in this case, we'll return 3 instead, despite the fact that it does not, the second list, right, does not have any value for their node, right? So it's a tail node in this case. So how do we really take care of this? How are we able to, perform the addition despite the fact that the list will have unequal amount of nodes? How do we do that? Well, we can use a while loop, right? A while loop to make sure that when list 1 has nodes, right? So L1 is going to be the list 1. I think the input is L1, yes. So when list 1 has nodes, right, let this iteration continue. Or when list 2 has nodes, right, keep iterating, keep traversing the nodes. Now one thing you will say is, okay, fine, we know that the while loop is going to suggest that when either of this list still has nodes, right, it should still continue. But how do we take care of the addition, right? How do we take care of the addition? And now by traversing the list, like I said before, we start from the root node and we check the next of this node, and then we are here, and next, and we are here. But by the time we do this here, right, and we get to this node, we don't have any more node to move to, right, which is going to be very difficult for us to make the addition. Now we can't add 3 plus null, right? So we need to take care of this case. We need to take care of this condition here. So when we do 3 plus null, we should be able to return 3, instead of an error, right? Normally you can't do an addition of an integer with I don't know, a whatever data type this is, which is the null data type anyway. So this is going to be possible. So meaning we have to replace null with 0, right? We have to replace null with 0, and then when we add 3 to 0, we'll still be able to return 3. Right? So our while loop is going to go this way. So our while loop will suggest that while there is still a node here, now traversing the list is not going to be in this way. So we have to like reassign values to our list, right? So we can say list 1 is going to be list 1 dot next, right? And we'll do this in the list 2 list 1 dot next will return so initially list 1 will be 4, right? Initially list 1, the current list 1 dot value, right, will be 4, and then we'll do the same thing. List 1 dot next will return 6, right? List 1 dot next will return so at this point list 1 will be here, and then we'll say list 1 dot next is going to be 3, right, which is this node here. This is how we'll be able to traverse the list. But when we are doing this, right, we won't directly set the values here, right? We won't directly set the values to this one. We can use a variable to keep track of the current node we are using, right? And then when we set the next value of this node, we'll be able to jump from the head to the next node. And in the case where there is no node, we'll simply, instead of setting the value of the node to our current variable, right, I'll call this value 1, right, v1 for value 1 of the list 1, right? If list 1 has a value, right, so let me do this. I'll say if list 1 has a value, right, return the value of the node. So I'll say list 1 dot value, else we should return 0. Then we'll be able to do the same thing for value 2 of list 2. So if list 2 dot value, right, return list 2's value, else return 0 as well. And then we'll perform the addition. So we'll call this total, right? I usually like to call it total. Then when we call total, right, we'll add the values at this point. So for v1 and v2, v1 plus v2, whatever v1 returns, right, whether the list value or the node's value or 0, right, it doesn't matter, we'll still be able to get a valid total at the end of the day, right? So when we add these values, right, we have a total. Now we need to create a node and we need to carry out some values because we are not guaranteed that total will return a single digit value, right? In this case, so let's go back to the question, right? So this is 243,564, right? 243,564, right? In this case, for the first iteration, right, we'll get 7, right? Now if you do 7 divided by 10, you will have 0, right? So and the value we'll carry out is the remainder of that division, which is still 7, right? So the value we'll carry out 0 and we'll keep 7, right? So our new node now will be 7, okay? And then we'll set the next for this. So the next time we calculate again, right, this time around is going to be 4 plus 6, which is 10. So we have to divide 10 by 10, which is going to be left with 1. Now 1 is the value we carry out, right? It's not the value we create a node with. What we create a node with is going to be the remainder of this division. Now the remainder of this division is going to be equal to 0, right? When you divide 10 by 10, the remaining value is 0, right? So we create a node with 0 and then we add that node to our list that we are building up, the results list. In this case, it's going to be equal to 0. And then the value we carried out now, we need to make sure that in the next iteration, when we are finding the total, right, we need to make sure that we always add the carried out value. So I'll call this plus C, right? Whatever value we carried out previously, which is 1 in this case, right, we need to ensure that we always add it in our so this is going to be in our total addition, right? So in this case, the next iteration will have 7, right? In the next iteration, when we add 3 and 4, right, we'll get 7, and the value we carried out initially was 1, right? Then we'll add 1 to this, so this is going to be equal to 8, and we'll add 8. Now we can't build the list in place, right? So meaning we have to create a dummy list and then set the values, the next value, into that list. Okay, so that's really what we need to do in order for us to solve this question. I know I probably took a lot of time to explain this, but I'm just ensuring that the question is properly understood. And the code for that is this. So I already submitted this code. Like I said, sorry. Okay, that was strange, but a little bit strange. I don't know why it's overflowing, but again, it's alright. So now you can see we have a dummy node which I called a results node, right? Our results node, so we use this as a placeholder to traverse the results node itself, so that we'll be able to set the next node into the results node. Otherwise, we can't directly say result node.next here. That won't work. So we need to create a placeholder, right, for it, and we set it there. Now, the carried value initially will be 0. It doesn't matter what the result of the addition is going to be. Once the carried value is 0, it doesn't affect anything, right? So now you can see we use a while loop and say while there is still node in L1, or there are still nodes in L2, in other words, while L1 list 1 is not null, and the list 2 is not null, or there is a carried value. Now I will explain why we have all carried value here, right? I will explain that in a minute. So what we need to do is to find value 1 and value 2. Now value 1 is going to be the value of the node if there is. Otherwise, if the node is null, then we set this to 0. And then we'll do the same thing here as well. And then we find the total by summing up the values in the nodes, right? So value 1 plus value 2, and is simply the value of list 1, which is value 1. Value of list 2 is value 2, and then we add the carried value to it. Now, how do we calculate the carried value? Well, if we divide it by 10, right, the result is what we carry away, right? And then we create a new node. Now that new node is what we're going to set into our results node, and we'll do that with the help of our current node, right? Current node dot next, right, is going to be the new node we set into our dummy list, which is results node, right? So I should have called this results list instead of results node, but anyways, that still works. Then we set the next to the new node that we just found here, right? And we found that the node's value is simply the remainder of the division of the total by 10. Now the modulus operator or the modulo operator will return the remainder of the division, right? So we take this value, okay, and then we set it to our new node, right? So we create a new node and we set current.next to the new node, right? And then we take the current node, right, which is at this point, so we'll set current node is equal to current node dot next. Now dot next will be none at this point, but we want to set current node so that we'll be able to insert the next node once we calculate it at this point, right, into our result result list. I don't know why I call this result node. Now that I'm reading this, I'm just not happy with it. But anyways, that's what we need to do. And then we need to reset the list 1 and list 2 to their next values or next nodes, because we need to what? Traverse the list. So we need to point to the next node and the next node and the next node. And at the end of the day, we'll return result.next. Now, why do we return result.next? We return the result.next because results node was initially created with a fake value. In this case, this is 0, right? And this is not going to be the value of our list at the end of the day, or the head of our list at the end of the day. We don't have 0 as the leading value, right? So we need to return next. Now, let me explain why we had carried value here as one of the conditions to continue iterating the list. Well, in the case where, let's say for example, right, we added the values, I'll say 7, 3, right? That's 10 already. And then we have another 7 and 3 here, right? So if you do this, this will be 10, right? So write the 0. Okay, in this case we can't have 0. Let's say for example we had 7 and 1, 7, 3, and 9 and 0. Yeah, so let's do something like this. So we start adding the values from the left, sorry. So this will be 8, this will be 10, so we write 0, we carry our 1, right? This will be 10 again, right? So we need to write 0 and carry out 1, right? And then we'll just make an addition of the invisible values we have here. Okay, this case we have 0 and 0, so we can't add any value, so we return 1 here. This will be the resulting list from this addition if we had done this. Now, what you would have expected is to have a node, a resulting list with the same amount of node as as the original input, right? But we have more, right? So meaning the value we carried out has to be added at some point, right? So meaning if we carry a value out and the value existed, and if we carried a value out, right, in this case this would have been 10, right? And we added 10 to 9 here, right? So here we have another 10 again. We can't store a node like this, right, with 10. We can't store 10 directly here like this. This is impossible. The question says we shouldn't do that. We should have a node with single digit values. So in case we have 10 here, right, we'll add to keep 0 and carry out 1. Now 1 is carried out, so now 1 exists. This is not the result of our list. This is incomplete, right? So we need to find a way to store 1 back into the resulting list. So for us to do that, we'll simply take the 1 again. Since there is a value here, right, we still need to continue with the loop, right, with the while loop. So the while loop says as long as there is a value for any of the nodes, right, in this case whether it's the left or right node, as long as there's a value for list 1 or list 2, right, list 2, or there's a value in our there's a carried out value, then we need to continue with the addition. Now you can argue now that okay, list 1 and list 2 do not have any values here, so this is null, right, and this is another null, right? These are both null, but we'll still be able to do the addition because we said for us to do the addition we need to create a value 1 and value 2. Now value 1 is going to be the list 1 value if the list 1 actually exists. Otherwise it's going to be 0. So in this case here, that condition will work perfectly, right? So we'll have 0 here and then 0, and then the addition will be made with those value plus the carried out value. So in this case we'll have 0 plus 0 plus 1 is going to be 1. So we'll find we'll divide this by 10, so this is going to be 0, right? We can't divide 1 by 10 and have a natural value. Now the remainder of the division of 1 by 10 is going to be equal to 1, so we keep 1 here as our new node, right? So we'll put 1 here, and then there is no more value carried out. In this case, the carried out value will be 0, and then we know, because this is 0, this is going to be a falsy value, right? So our loop will only continue if there is at least one truthy value, and in this case there are no truthy value. C is equal to 0, which is falsy, right? This is falsy, and we can't continue the iteration, so we create a new node with this value that was returned here. And that is how we'll be able to calculate the we'll be able to add the values by traversing the list simultaneously, right? And yeah, so that's all for today, and I have exhausted my time, and I just want to say today's stream is just take it like a trailer for tomorrow's stream. Tomorrow's stream, I will make an effort, since it's the weekend, I'll make an effort to start early and have more time to explain more questions and solve more questions as well. In any case, it's been good. Today has been fantastic, and have a great evening. It's Friday, so enjoy your Friday evening and have fun. Keep coding and stay coding. Now let's check if there are any questions in the chat. There are no questions. Oh, some came on time. Today was a hard working stream. Yeah, I mean, I actually, struggled to make the stream today. But anyways, I'm still here. I did it, and it's been day 96, which is really good. Yeah, thank you very much, guys. And we shall continue tomorrow. Have a good night. Bye.